All right, let's dive in. Today, we're going to demystify the electronics behind a DIY mini CNC machine. You know, those awesome little robots that can draw or engrave. We're going to take what looks like just a pile of parts and turn it into a super precise, creative machine. So let's get right to it. So, I bet you've been there. You've got this awesome idea for a robot that can draw or cut or engrave something cool. But then you hit that wall. The idea of writing all that complex, low-level code just to control every single pulse of a motor, every tiny little movement, it just feels overwhelming, right? Well, what if I told you there's a massive shortcut?
Okay, say hello to GRBL. And yeah, it's pronounced Gerbil. This thing is a brilliant piece of open source software. You basically just load it onto a super cheap Arduino board and boom, that little board instantly becomes the dedicated brain for your machine. It does all the hard work, all the heavy lifting, so you don't have to.
So here's our game plan for today. We're going to quickly cover the why this is so cool, and then we'll jump into the how with 3 simple steps. First, we'll install the brain. Then we connect the nerves, and finally, we'll learn the language. Stick with me, and by the end of this, you'll have made your very first creation. All right, first up, let's really dig into why GRBL is such a total game changer for anyone building their own stuff. Okay, just look at this comparison. It really tells the whole story. Without GRBL, the old way, man, you had to be the programmer, the mathematician, the engineer all rolled into one. You'd be painstakingly coding every single motor movement. But with GRBL, you just load this pre-built firmware one time. That's it. It handles all the complicated math for you. All you have to do is send it simple text commands from your PC. It's literally the difference between having to build a car from scratch, from raw metal, versus someone just handing you the keys and saying, go for a drive. All right, enough talk. Let's get practical. Step 1, we're going to give our machine its intelligence. We're going to flash that GRBL firmware right onto its Arduino brain. And you know what? The process is so much simpler than you'd think. You just open up the free Arduino software, the IDE. You go find and install the GRBL library. Then you open the pre-made example file they give you. It's called GRBL Upload. And you just hit the upload button. That's literally it. No custom coding whatsoever, just a few clicks. And just like that, poof, the job is done. Your little Arduino board has been totally transformed. It's not just a blank slate anymore. It is now a specialist, a dedicated CNC controller, just sitting there, ready and waiting for your commands. Okay, step 2. The brain is installed. Now it's time to connect the nerves. And by nerves, I mean the wires that run from our new controller brain out to the muscles of the machine, the stepper motors. Now, knowing where to plug things in is, well, it's pretty crucial. So think of this as your cheat sheet. GRBL has a standard layout, so you don't have to guess. For each axis, X, Y, and Z, there's a step pin and a direction pin. The step pin basically gets a little pulse that says, move one tiny step. The direction pin just says, and move this way. You just hook up your motor drivers to these specific pins, plus that master enable pin on D8, which basically wakes up all the motors at once. And for those of you who want to level up your machine later on, GRBL has you covered there too. You can connect things like limit switches, we call them end stops, which are just little buttons that tell the machine, hey, you've reached the end, stop moving. You can also control your laser's power or a spindle speed using something called a PWM signal, which is really just a fancy way of telling it how bright or how fast to go. Okay, check it out. The hardware is done. The brain's installed, the nerves are all connected. Now we get to the really fun part, learning to speak the language that our new robot understands. And that language is called G-code. Now, don't let the name scare you off. It's really just a simple series of text commands, one line at a time. Each line is a single, simple instruction, telling the machine exactly where to go, how fast to get there, and whether its tools should be on or off. Take a look at this. This little block of text right here. That is everything you need to tell your machine to draw a perfect 20 by 20 millimeter square. I know, it might look a little cryptic at first glance, but trust me, let's break it down line by line. You'll see it's actually super logical. So these first few lines are just the setup commands, kind of like setting the ground rules. G21 just tells the machine, hey, just so you know, we're working in millimeters. G90 says, and by the way, all the positions I'm about to give you are based on a fixed starting point. Easy enough? Then M3 S1000 is the command to turn the tool on, like a laser or a spindle, and turn it on at full power. Okay, now for the action, the good stuff.
G0 is a rapid move. Think of it as get there as fast as you can. So G0, X0, Y0 zips the tool over to our starting corner at 0, 0. Then we switch to G1, which is a controlled straight line move. We tell it to go to X20, Y0 at a feed rate of 500. Bam, that's the first side of our square. Then we just keep going. Move to X20, Y20, then over to X0, Y20, and finally back home to X0, Y0 to complete the square. See, you're literally just telling it the coordinates of each corner. So, you might be wondering, how do you actually send this text to the machine? Well, you use a free piece of software on your computer called a G-code sender. There are great ones out there like Universal G-code Sender, or UGS, and Laser GRBL. This program is basically the dashboard for your machine. It lets you load up a whole file of this code, manually move the axes around, and then, when you're ready, you just press a button to send your entire creation over a USB cable. Okay, so our machine has drawn the square, but like any good project, we need to finish the job up and clean up after ourselves. And these last two commands are just that, cleanup. M5 is the opposite of M3. It turns the tool off. You definitely don't want to forget that one. And then G0, X0, Y0 just sends the machine zipping back to its home position so it's ready for whatever you want to do next. And there you have it. I mean, think about it. In just a few really straightforward steps, you've taken a cheap Arduino, some motors, and a bunch of wires, and you've given it a brain, you've given it nerves, and you've taught it a language. You've created a robot that can follow your commands with amazing precision. You know, the most important thing to take away from all this is that controlling a CNC machine isn't some kind of dark art reserved for coding geniuses anymore. Thanks to GRBL, it's something that anyone can do. A simple square, that's just the beginning. It's just proof of concept. The real question is, now that you have this power at your fingertips, what are you going to create next?